In this video, we're going to talk about the chemical formula of a transition metal and how to name a transition metal. Now, a good student of chemistry actually knows that a transition metal possesses variable oxidation states. So, at times, for chemistry students who have the basic idea of just normal naming of compounds, it's not needful and it's not just enough to be able to tell, okay, this is the chemical formula of such a compound. Now, you have to write the name of um, a transition metal compound. We have to first what find out what the charge of the transition metal. In this case, we have iron. Find out the charge of the transition metal in that compound. After finding out the charge of the metal of the transition metal in that compound, we can now what be able to write the chemical formula by writing firstly the name of the metal, then enclosing the charge in what in a Roman numeral as the right was the the non-atomic non-metallic ion or radical with it. For example, in this case we have ion, we have FeCl3. Now, looking at this, Fe refers to what ion, but we don't know what is going to be here. Refers to ion, right? Now, firstly, this refers to ion. So let's go back. Now we have chlorine 3. Now you know that in normal what compound, a compound has what oxidation state of 0, which means it's electrically neutral, and that means the sum of the positive charges balanced without negative charges. Now in this case we have what Fe, which you don't know is this thing is charge, and that of 3 chlorine, we know chlorine is minus 3 minus 1, so that of 3 is going to give us 3 minus 1 equals to 0. So we have our Fe minus 3 equals to 0. So that of Fe is going to be 3 plus 3. By the time we take this minus to this other side, it's going to have plus 3. So now, which means now this what oxidation state of ion, or the charge possessed by ion right here is what going to be plus 3. I will enclose that 3 in Roman numerals inside a parenthesis. Then ion, that's going to give us ion 3. Then this is what chlorine what ion, so it's going to turn to chloride. So that's ion 3 chloride. Also we have here FeCl2. Now how are we going to write that for FeCl2? Fe is a chemical symbol for ion, which we write ion. Then what about LCl2? We know that Cl2 here is Cl as a charge of minus 1. So 2Cl2 means we have 2 what chlorine ions. Now let's determine the charge of ion in this. Like I said earlier, the oxidation state of a compound is going to be 0, and we have Fe plus 2 minus 1 equals to 0. We're going to have Fe minus 2 equals 0. The ion is going to have a charge of plus 2. So we're going to include this, going to turn ion to chloride. Now let's work on a kind of example. Let's look up copper, CuBr. And let's go CuBr2. Now, in this case, Cu represents what's copper. That is the chemical symbol for copper. And this represents what? Bromide ion. This gives us Cu. We don't know the charge X, and bromide, which we know is minus 1. So I said in an electrically neutral, a compound has to be electrically neutral, which means it doesn't possess any charge, because the positive charge is going to be balanced by the negative charges, and we're going to have Cu plus 2. Sorry, we have just one molecule of bromide, so that's minus 1 equals 0. So Cu plus minus gives us minus 1 equals 0. Cu, this minus is going to come over here and turn to plus. That's plus 1. And this gives us iron, copper, 1 bromide. Now moving on to copper, CuPr2. This represents copper, and this represents bromide also. Now we have Cu plus 2. Like we said, we know that the ionic charge of a bromide atom, which is bromide, is minus 1. Minus 1 equals 0. So we have C is going to goes to plus 2. So which means copper has a charge of plus 2 here, but it